Hello everyone and welcome back to the maths. In this video, we are going to learn about functions, specifically regarding domain and range of function. This video is based on the IGCSE AS and A-Level Pure Mathematics 1, and it's also open to any students out there with any curriculum who are currently learning functions. Before we begin, let's try to review what is a function. So function is something that relates an input to an output. For example, if we have an orange, and let's say that the orange is an input, we have a blender, which is the function. Remember that function is something that relates an input to an output. So an input is going to be an orange, and the function is going to be the blender. You might be guessing what the output actually is, and the output is going to be an orange juice. So the function is used to process an input to an output. The blender is used to process an orange to orange juice. So that is a function in simple terms. Now, in mathematics, a function is represented by an expression. If x is the input and we have a function usually denoted as f, the output is going to be an expression on the right side of the equation. Let's try to see an example. It's going to be f of x is equal to x plus 2. Now, the left side is pronounced f of x. So f, the f letter, is going to denote the function. It doesn't really mean anything much. It's just going to denote that it is a function. And then the x is going to be the input. And then the right side, the expression on the right side, is going to be the output. You will see later that the output is going to be a value as well. So the input, x, is a value, and then x plus 2 is also a value. Another way that we can rewrite the expression on the left is like this. So we can try to write it as y equals to x plus 2. Now, which writings are right? Both writings are actually fine. Both writings are okay. Now, let's try to see what is defined as domain and range. Domain is going to be the set of eligible input values, simply the x values, and range is going to be the set of output values, simply the f of x values. So you input the x value defined in the domain into the function, and you get the output values, which are the range. Range is also sometimes called codomain, but usually we call it just as range. Now let's try to see an example. F of x is equal to x plus 2 for x between minus 1 and 2, where minus 1 and 2 are included. In this case, we can try to draw the graph, we can try to illustrate it, and we can try to denote the coordinates of the left and right boundaries, which are minus 1, 1 and 2, 4. Now, remember again that domain is the set of eligible x values. So the domain is going to be from minus 1 to 2. And for the range, it's going to be the set of eligible output values, where in this case, it's going to be from 1 to 4, as you can see in the graph. Therefore, we know that the domain is going to be from minus 1 to 2, where minus 1 and 2 are included, and the range is going to be from 1 to 4, where 1 and 4 are also included. So this is how we write the domain and the range of a function. Let's try to see another example. In this case, we have a parabolic function, and the domain is going to be from minus 1 to 4, where minus 1 and 4 are included. Let's try to draw the graph first. Now, in this case, as we can see, we have a vertex. The vertex is going to be 2, minus 4. And now, let's try to see the domain. So the domain, again, it's going to be the set of eligible x value, which ranges from minus 1 to 4, as we discussed previously. And then the range are going to be from the vertex to the top. So it's not going to be from 0 to 5, but it's going to be from minus 4 to 5. So we need to be careful when we are working with a parabolic curve. So to summarize, the domain is going to be from minus 1 to 4, and the range is going to be from minus 4 to 5. Now, let's try to see another example. So we have the same quadratic function, but let's say we change the domain. So the domain now ranges from 3 to 5. We can try to draw the graph again, and it's going to look like this. And as you can see, the vertex is not included in this case. If the vertex is not included in the case, then we can just try to test for the left and right boundaries. So the coordinates of the left and right boundaries are going to be these. And then we can just try to draw the domain and the range for this graph. And we can try to conclude that the domain is from 3 to 5 and the range is from -3 to 5. Again, for a quadratic function, we need to check whether the vertex is included or not. Right, this one is going to be a different example. So we have a graph of a function, and we need to state the domain and the range represented by these graphs. First, we don't need to know what the function is. That's the thing. If you have this type of problem, you don't really need to care about what the function is. You just need to see the graph, and then you just need to determine the domain and the range. Now, in this case, we know that the domain is going to range from -1 to 2, and then the range is going to range from 1 to 7. So there you go. The domain is from -1 to 2. The range is from 1 to 7. Right, another example. In this case, we don't really need to know what the function is, even though you can try to guess it's actually a parabolic curve. But yeah, we just need to find what the domain and the range. So the domain, again, is going to be the set of eligible x value, which means the domain is from -3 to 4, and the range, because we have a vertex and the vertex is included, so the range is going to be from -1 to 15. From the examples that we saw before, we can try to categorize. There are two types of function. The first one is going to be a quadratic function, and the second one, the rest of them. It can be linear, cubic function, it can be an exponential. It's categorized in the second category, which is anything else aside from a quadratic function. So how to deal with these two categories of function? The first one, the quadratic, we know that we can find the x and y of the boundaries, and we can also find the coordinates of the vertex. We also need to make sure whether the vertex is included or not. And then for the second category of function, we just need to find the x and y of the boundaries. So it's going to be very simple if it's not a quadratic function. Let's try to take a look at a harder example. The function f of x equals to -x squared plus mx minus 5 is defined for x element real, which simply means x is any real number. And we need to find the range of this function in terms of m. Like we learned before, for a quadratic function, we need to check the boundaries and the vertex first. But since there are no well-defined boundaries for x, because x can be any real number, then the range of this function is determined from the extreme value of the quadratic function, which means it is determined from the vertex. So we can try to calculate the extreme value, and remember, since the coefficient of x squared is negative, that means the extreme value is a maximum point, which means this formula will result in a maximum value of the function. So we can try to input the ABC values just like what we learned before in the quadratics, and we get that f of x maximum is going to be m squared minus 20 over 4. Now, let's try to remember that this is f of x maximum, so that means any other values should be less than this. Therefore, we can try to write the range as f of x less than or equal to m squared minus 20 over 4. So that's how we write the range in this kind of problem. Right, next example. The domain of the function f of x equals to x squared minus 4x is between a and a plus 2 if the range of the function is -3 less than or equal to fx less than or equal to 5, we need to find the possible values of a. Right, so what should we do first? First, we need to find the coordinate of vertex, because we need to know whether the vertex is included or not. We don't know what the domain is, but we know the value of the range. So we want to check whether the y value of the vertex is included in the range of this function. So we can try to input the ABC values in the formula, and we got that the coordinate of vertex is 2, minus 4. Now, let's try to take a look at the extreme value, which is minus 4. And this is outside the range defined in the function. So therefore, we know that the vertex is not included. Next step is to find the a. If we want to find the a, we just have to input the f of x value, which is, in this case, -3. I tried to choose -3. And then we can try to do the usual factorization, and we got that a is equal to 1 or a equals to 3. So we have two different values, but we need to check which one is correct. Let's try to see the first case, where a is equal to 1. If a is equal to 1, and then we input the a value into the function, we get -3. If we input a plus 2, which is 3 in this case, it's going to yield -3 as well. And we know that the range of the function should be -3 to -3. And we know that this is not correct because it doesn't match the range defined in the problem, which is -3 to 5. Therefore, we need to take a look at the second case. For the second case, we know that a is equal to 3. If we input the a value into the function, it's going to give us -3. And a plus 2 should be 5, and f of 5 is going to be 5. Now, the range of the function is going to be -3 to 5. This is the same as what's stated in the problem, so we know this one is correct. Therefore, the a value that is possible is a equals to 3. Right, these are the exercise that I've prepared for you guys, and as usual, I will leave the answer key in the description box below. I have also prepared two problems regarding the heart example that we discussed before, and again, the answer is also in the description box. Right, so that's it for this video. In this video, we learn about the domain and range of functions. What do you think about this video? Please leave a comment and don't forget to leave a like and don't forget to subscribe. I'll see you on the next video. Thank you.